Hello and welcome back into serious manipulating. Just a few tricks just to play around and gain knowledge. We're going to be using today a very famous series, 1 over r squared, which a lot of you might know the actual answer to this particular convergent series. I wrote it here as L because it doesn't really matter even if we don't know what the actual sum to infinity is. We can give the answers of what I'm about to ask you in terms of L. So for those who know this, is of course, as you know it, pi squared over 6. So what he actually says, it says 1 plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared plus dot 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 forever. The sum to infinity is in fact bizarrely pi squared over 6, one of the celebrated results that most people that show interest in maths are aware of. So what are we going to do with this? Well, I have a question here which comes from one of my special papers, but we're going to use it for manipulations today. So we're going to just use this fact, take this as a given, and find other sum to infinities which are related to this particular one. So the first part of this question that I can make is, of course, if this is true, okay, then what is the answer to this particular one? 1 over 2 squared plus 1 over 4 squared plus 1 over 6 squared plus 1 over 8 squared plus dot 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 forever. Okay, and if you know, we're going to be using L, where L is, of course, for those who know, pi squared over 6, but we're going to give the answer in terms of L. So if that particular answer is L, then what is that? Okay, probably the best way, and sometimes it's worth a try when you're having a series, is actually to write in sigma notation, because it can actually make life a lot easier. So this is one of these cases where in fact having it in sigma is probably easier, or I would have thought it is. So if we write a general term, this of course goes to infinity, and look what a general term of this particular series will be. Is clearly even numbers, which we can write as 2r, so 2, 4, 6 and so on, or squared, and in order to run correctly it needs to run from r is equal to 1 to infinity. So this is the question, and we have it now in sigma notation. Of course we can manipulate a sigma very easily, so we can write here 1 over 4r squared, which of course now we can use the linearity of the sigma operator. So this a quarter we can write at the front of the sigma from r is equal to 1 to infinity, and of course is 1 over r squared, and of course this particular sum is known to be L, or pi squared over 6. So for those who are using L, the answer is of course a quarter L, or for those who are using the pi squared over 6, this will be pi squared over 6 times a quarter, pi squared over 24. Okay, but it doesn't matter. The quarter L is good enough for this particular question. So that's the first part, or the first manipulation done for what we're gonna do today. So naturally the next question to ask is something which of course is, okay, this is the evens, the even denominators. What about if we do the odds, starting with 1 plus 1 over 3 squared plus 1 over 5 squared plus 1 over 7 squared plus dot 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 forever. So let me just clear the line above it and let's have a little think about it. Okay, I don't know if I want to do it 2 different ways to keep you happy, or to convince you, not to keep you happy. You know, in at GCSE or even lower school, when you're doing tree diagrams and we're drawing discs out of a box or something like this, and they are, for example, we doing 2 draws. Let's say in the bag there's blue, black and red, and the question is asking you what's the probability that we're going to draw different color discs. And of course, if you do it the long way, there are 6 branches that you're going to have to work out. Where in fact, most people, after you've done 3 diagrams for a little while, you just think to yourself, you know what, how about I find what's the probability of getting the same color and then do 1 minus. So it's kind of like a similar idea here, perhaps we can use. Okay, if we worked out that the gaps in between, the 1/2 squared and 1/4 squared plus 1/6 squared plus 1/8 squared and so on, it was 1/4 L. Oops. Shouldn't that mean that the rest of the terms, again to infinity, shouldn't that mean that's perhaps 3/4 L? Personally, I think it's okay, and I probably would have argued the case like that. Series can sometimes be a bit funny, and I'm not going to go to complicated stuff because at the moment this lecture is not for undergrads. It's for people sort of like doing A levels and try to get a few ideas about how to manipulate series. But perhaps we can actually do it with a little bit of simple algebra, which essentially is what I've just quoted up there. So you can say, all right, we try to find what is this particular thing. So quite clearly, I can argue the case as follows. I can say this is 1 plus 1/2 squared, but of course I just added 1/2 squared. So underneath it, I'm going to subtract it, plus my 1/3 squared. That's of course there, plus a 1/4 squared, which I don't have in there, so I need to subtract it. So this basically will cancel now. I don't know if you can see what I'm trying to do in there. Of course, that's nothing else to add there. Plus 1/6 squared minus 1/6 squared plus, let's do one more term, plus 1/7 squared plus 1/8 squared, and of course this. Let's first of all check that this line is exactly the same as this line here. Of course, plus, I'll put the plus dot 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 outside, so that means for both these lines here. So if you look at what that actually says, is 1, this cancel, plus 1/3 squared, this cancel, plus 1/5 squared, this of course will cancel, and so on. So if you look at what these things are, this top line is of course your sigma from r is equal to 1 to infinity of 1/r squared, because it has every single number, and we need to subtract, because of course we're looking now across, the sum of 1/2r all squared from r is equal to 1 to infinity, and of course this is the answer that part A, I've just rubbed it off, which of course we knew it was of course 1/4 L. So as I just explained, it's not really anything different that I'm doing. I've just laid it out in a different way, perhaps to convince yourself it is in fact what we think it is. So L minus 1/4 L is 3/4 L, or for those who are using pi squared over 6 as the answer, that should be pi squared over 6 there, so that's 3/24, so it's pi squared over 8 basically. Okay, so this is now the second series to which we managed to sum. Okay, what's the third thing we can do? What have I got up there? This one is exactly the same as the original series, but the terms alternate in sign. So it goes 1 minus 1/2 squared plus the same, but now minus. So we're trying to actually find what is this particular sum. So 1 minus 1/2 squared plus 1/3 squared minus 1/4 squared plus 1/5 squared plus dot dot dot. So that's part C of the question. In terms of L, what's the answer to this particular series? Okay, what can we do with something like that? We can write in sigma notation. First of all, the general term is, of course, on the denominator we have an r squared, and it will start from r is equal to 1, because don't forget that is a 1 squared there as well. But in order to get the terms to alternate, we need a -1 term on the top, and in order to produce the correct signs, we need the first term to be positive. So if we put there r, now it's going to be to the 1, so the first term is going to be negative here and positive there, so it's the negative of what we got up there. So the way to make it work, you can either put there +1 or -1, it doesn't really matter. So this is in fact a general term for this particular series. Does that actually help us as we have it up there? Perhaps not. What can we do? Maybe we can use some of the results on part A and part B that we have already established. So what can we actually say? Well, let's rewrite this as 1 plus 1/3 squared. So I'm grouping the positive terms together. And of course it would have been 1/7 squared plus ... And so that's equal. And from that we need to subtract minus 1/2 squared. This minus this one has a plus, of course, inside the bracket. 4 squared plus 1/6 squared plus ... That's a lot better, because in fact that's part A and part B put together. So in fact, if we were dealing with that and I hadn't broken it as part A and part B, it would have required a little bit of work, perhaps, to think about writing it in this particular form and then seek the answer to this bracket separately and this bracket separately. So this one, I can't quite remember what was the answer to this one. Was it 3/4 L for this one? We just found it a minute ago and I can't quite remember what's the answer to this one. The odd ones, I think, was 3/4 L, and the evens ones, was it 1/4 L? So in fact, if that was the correct answer, so I do apologize, I rubbed it off and I can't remember the answer now. Okay, is in fact 1/2 L, or pi squared over 12. I hope I haven't made a mistake with this particular one and I'm not quoting the wrong things from the previous part A and part B. So that's the answer from part B, and this is the answer from part A as I presented it. Okay, so this is the answer to part C. And I'm going to do one more. Let's see what else we can actually do with this particular one. What have I got in the menu? Hopefully nothing too hard. This is not meant to be some groundbreaking stuff. It's kind of like try to help you see how you can group terms and how you can manipulate in order to get answers. This one is actually quite bizarre. Is 1/1 squared plus 1/2 squared minus 8/3 squared plus 1/4 squared plus 1/5 squared minus 8/6 squared. I'm just checking that I'm following the pattern correctly, and I think I'm getting the idea now probably what the question is asking. So two more terms, 7, 8, and then minus, and then it's 8 again on the top, and now is 9 squared plus ... forever. So this is what we are being asked to find in terms of L. And of course L is this particular sum. What can we do? First of all, can we write this in sigma notation? I wouldn't know at the moment at first glance, and I wouldn't tie my brain. I personally, just at first glance, I don't think it can be written as a single sigma, but at the moment, perhaps we need to approach this a little bit differently. So try to give you a different technique. What can we do in there? Okay, how about we try to create this particular series, because like I've done by adding and subtracting terms. So I can actually say this is going to be equal definitely to 1/1 squared plus 1/2 squared plus 1/3 squared, but of course I have to balance and end up back to -8/3 squared. So I need to subtract now. Let me just write it, 9/3 3 squared. So if you think of this as lots of 1 over 3 squared, we got 1 minus 9, which is minus 8. And then we can continue. Plus 1 over 4 squared, plus 1 over 5 squared. And similarly, I'm going to add again 1 over 6 squared, but in order to balance it, I need to subtract 9 lots over 6 squared. And the same thing. And let's see if that helps us and what happens. By writing the first, it's actually 9 terms, quite a few terms I have to write for this. Plus dot dot dot, and of course for this term and to balance it and take it back down to negative 8 over 9 squared, plus dot dot dot. Okay, what happens here now? Well, quite clearly, if I add it not like this, but this row first and then this row afterwards, this row forever is my L. This is just this bit here. What about this thing here? Can I write it perhaps a little bit different? Well, the best way to write it as is, let me just move it a little bit further down because I think this is too low for me to write there. So let's rub this off. These terms here, probably I'll write them in sigma notation. What do they look like? First of all, they all have a minus, and I made a mistake in there. That should be, of course, a 9 as well, in order to give me the 8. I got carried away, so that should be, of course, yes, it's correct. It should be all 9s. So they all have 9s. And if I write in sigma notation, actually let me write first of all in normal notation so we can all see it before we move into sigma. So if we factorize the minus 9 from all of those, I'm going to get 1 over 3 squared plus 1 over 6 squared plus 1 over 9 squared plus, of course, if I wrote one more, it would have been 12 squared plus dot dot dot. So I'm going to write this now in sigma notation in the hope that this will help me see my answer. So that's going to be L minus 9, and this written as with the sigma operator is going to be multiples of 3, 6, 9, 12. So it's on the denominator 3r all squared. So when I put r is equal to 1, it gives me this, r is equal to 2. So it runs from r is equal to 1 to infinity. Okay, let's clear this a little bit. Let's make some space perhaps on the top line here, because I can't write any lower. I don't even know if it's visible in the video if I write any lower than that. I can never remember how much of my board to the video screen is covering. So here we go. This is equal to L minus, and this now we can manipulate this sigma. We got a 9 at the front. From r is equal to 1 to infinity, and of course it will square out to 1 over 9r squared, which of course this 1/9 is a constant, is independent of the summation in r, so I can pull it outside. Let me just write the line. It doesn't really matter. It will make the video a little bit longer as well. Times 1/9, so this is the 9th gone outside, and we got, of course, the sum of 1 over r squared from r is equal to 1 to infinity. This, of course, will be 1, and of course this sigma is just nothing but L. So the answer for this will be L minus L. So in fact, the series that I just gave you in part D sums to 0. I hope you found this kind of useful and interesting, something on a different theme to what I've been doing with series recently. And on this note, who's laughing now?